Hey guys, another chapter 6 video here for you. We are on topic 6.5, and for this video we are going to work on how can you solve an exponential equation. So we've been graphing exponentials, we've looked at compounding and simple interest, and now we are just going to get into some like what I would call straight up algebra, just solving for x. So we're going to do some examples because it's probably easiest just to show you a few. Here is a pretty easy example of a problem that is an exponential equation. 3 to the x plus 1 power equals 3 to the 4th power. We are going to solve for x. Now the reason I say this one is so easy is imagine putting a line down the middle and saying let's get x by itself. Well, because of the exponential piece of it, what I look at and I notice right away is they have equal bases. It's 3 to a power and 3 to a power. So because of that equal basis, what I really know is that x plus 1 just has to equal 4. Well, that'll be easy to solve. Take the 1 away, and you get 4 take away 1 is 3. We already know our answer. X must be equal to 3. We can totally check it too and see if we're right. To check it, we write down the original equation. 3 to the x plus 1 equals 3 to the 4th. But we think x, which I'm going to circle, is 3. So we just change it to a 3 and we see if it works. 3 to the 3 plus 1, well that'd be 3 to the 4th equals 3 to the 4th. Yeah, absolutely. 3 to the 4th does equal 3 to the 4th. In fact, it equals 81 and 81. So it definitely checks out. There's our solution. X is equal to 3. And we've double checked it. Alright, so let me show you another one here. Example 2. Here's another one that I would say is fairly easy. 10 to the 2x power equals 10 to the x minus 1. Why am I saying it's fairly easy? Because when I put the line down the middle, I'm saying equal bases, 10 and 10, they both have the same base, which really means just the powers have to be equal. 2x has to equal x minus 1. All right, well, let's get the x's together. We know how to do that. X is going to have to equal a negative 1. There's our solution. Again, you can check your answer on all of these. Watch the check on this one. I'm going to copy the problem. 10 to the 2x power equals 10 to the x minus 1. Where the x's are, I'm going to replace with my negative 1. So instead of 10 to the 2x, I'll have 10 to the 2 times negative 1. And then it'll be 10 to the negative 1 minus 1. Okay, so that would be 10 to the negative 2 and 10 to the negative 2. Equal answers. Or if you wanted to say 1 over 10 squared and 1 over 10 squared, that's 100th and 100th. They're equal. So the answer checks out. X equals negative 1's right. And I'm feeling pretty good about it. Okay, so let's look at another example. Example 3. This time, here is our problem. 5 to the x power equals 125. This one's not as easy because I'm thinking line down the middle, but where's my equal bases? I do not have equal bases, and that's where I'm like, this one's going to get me a little bit stuck. What I really wish is I had equal bases. 5 to the x, I wish it equaled 5 to something else. Well, think about it. 125, isn't that the same as 5 to the 3rd power? 5 times 5 times 5. So I'm going to rewrite this problem so that it actually does have equal bases. Now I'm like, oh, this will be easy. That must mean x has to equal 3 so that the powers match up. Don't believe me? Well, let's check it. Remember the problem was 5 to the x equals 125? Now I'm going to do 5 to the 3rd. 5 times 5 times 5. 5 times 5 times 5 is 125, so check, it works. All you got to do is make some equal bases so you can solve. Okay, let's look at another one, example 4. Again, here's an example of when we don't have equal bases. 4 to the x equals 2 to the x minus 3. I wish that this problem would be easier, but without those equal bases, I always have to stop and think, what can I do to make them equal? So here's what I'm thinking. I'm going to change the number 4. What am I going to change it to? Well, I'm going to change it to 2 squared because technically 2 squared is 4, and so I'd still have 4 to the x. So I'm not really changing the problem, I'm just making it look different. 2 squared. Well, 2 squared to the x power is like 2 to the 2x. That's the same thing. Now I've got equal bases. 2 to the 2x equals 2 to the x minus 3. That means 2x has to equal x minus 3. Take the x away, we're going to get x equals a negative 3. That's our solution. Let's check it and see if we're right. So remember our problem was 4 to the x equals 2 to the x minus 3. Now I'm going to be doing 4 to the negative 3 equals 2 to the negative 3 minus 3. Let's see, let's rewrite this. That would be 4 to the negative 3 equals 2 to the negative 6. That'd be like 1 over 4/3 equals 1 over 2 to the 6, because we got to change those negative powers. 4 times 4 times 4 is 64, so we get 1 over 64. And then 2 to the 6th power is also 64, so yay, it matches up. 1/64 equals 1/64. So our answer is correct. All right, your turn. I'm going to have you try now. I'm going to give you 2 questions, and I want you to try to solve. Here are both of your questions. Go ahead and hit the pause button and see if you can do them on your own. Good luck. All right, you ready to check your answer? Let's see how you did on these. So for the first one, I don't see equal bases. I wish they both had a 6 as the base, but here's what's the good news. 6 to the 4th power, 6 times 6 times 6 times 6 is 1296. So that must mean x has to equal 4. Is that what you got? Did you figure out that 6 to the 4th power piece? I hope you did. Let's look at B. B is another one. There's no equal powers, but you know what? 9 can be rewritten as 3 squared because 3 times 3 is 9. So it's like 3 to the 2x power equals 3 to the x plus 2. Now I have matching bases again. They're both 3's. So 2x has to equal x plus 2. Take the x away, and x is equal to 2, and that's our answer. Alright guys, that wraps up our video. I hope you did okay on those U-try problems. Just remember, it's all about getting equal bases. If you can get equal bases, you can probably solve. I will definitely see you in class and see you in the next video.